and 3, right? So we have a binomial
Yeah.
expression that we start with. So this is called a binomial expression. And then we know, basically it's a technique to multiply it very fast, right? Just to, it's a pre-made thing that you can use to multiply and get the answer fast. Something like this. Okay. But of course, we all know that. But what we will try to do is we'll try to understand polynomial is basically a multiplication of polynomials, right? So we will try to understand polynomial multiplication, polynomial multiplication as much as we can do without using binomial theorem, and hopefully we'll arrive at the binomial theorem. Okay. So, well, first let's just discuss the rule. So if it is xy times zw, we all know how to multiply this, right? You just take all
Yeah.
possible combinations xz, xw, and yw, and then what is the one that I'm
YZ.
missing? Yz.
YZ.
Yeah. Okay. So that is the one that we are missing. So that's fine. Now, how about if we made this a little more complicated? Let's say we had not 2 but 3 factors. But of course, then we will have to have some
Do it two at
pattern.
a time.
Yeah, definitely one can do 2 at a time. But can we say what the answer will be? Can we explain the answer in the end? So because this is not an entirely general expression, you see, x is
I
common
mean,
to all. Yes.
one can do it in what do we say? There's obviously there'll be an x cube because there are three. There are a
Okay.
total of three x, so three expressions.
Right. Hmm.
Now there was a particular portion. Okay, now for the next term in the coefficient is x square. Now,
Yes.
but for that we find the coefficient.
Yeah, this is really the key. We want to find a method to find this. Yes.
Yeah.
So yeah, this is the discussion type class. Okay. So if anyone has anything to say, just say it in between. Yeah.
So one could say that the x square expressions are something like a1, a2 plus a2, a3 plus a3, a1 or something like that.
Is that true? What does x square mean? X square means that you're going to choose x from 2 of the boxes. So this is
Yeah.
like 3 boxes. And we're going to choose
Yeah.
one from each and append them and write. X square means you're going to
Yeah.
choose x from 2 of the boxes and not from the third box.
Yeah.
That means that from the third box, you're going to choose A3, A2, or A1. Yeah, and that's why you will get A3 or A2 or A1.
Oh, okay.
Either that makes sense to everyone. Yeah, if someone doesn't understand anything, again, please interrupt. Okay, so this is what it is. And now analogously, but still, just let's try to go through it. What would be the coefficient of x? I would like someone to explain this. Without saying that analogously it works.
Well, the way to explain would be the x would be formed by the multiplication of any constant term with at least one with one of the other two x with one of the other two brackets.
Yes, right. That makes sense. Basically, you're saying that you could choose x from exactly 1, right? Choose x from
Exactly one.
exactly one box. And it's clear that from the rest of the 2 boxes, you have to choose two of the AIs. So this will be just sum of 2 of the AIs, 2 AIs at a time, which of course in this case we can just write. So usually we just write it in this case. We have A1, A2, A1, A3, A1, A4. So immediately we see that polynomial multiplication has a very straightforward rather connection with just balls and boxes and combinatorial stuff, right? So this makes it clear that when we are trying to do this for more number of variables, okay, and this is really very important because even in the theory of equations is very important. So we will see it there. No, we will not see it there because that's not. So this class is more of a straightforward class. Okay. The harder aspects of it we will do in other classes. Okay. Today we'll just starting binomial theorem. So I don't want to go into, just want to cover the theory, basic stuff today. So this when we are multiplying this, we can analogously understand it, okay? But we understand that this balls into boxes thing must be understood very well, okay? So for that, we will just do a few counting problems of this kind, okay? Balls into boxes kind of problems. And then we will switch back to understanding polynomial multiplication. Okay, so I would like to start with a very simple question. Okay, we have most of you might have already seen this, but yeah, let's see, then you can tell me. So we have, let's say, let's just do for numbers. Okay, so here's a question. Okay, we have, let's say, 10 boxes, okay, and 22 balls, so all distinct, meaning that all boxes and balls, everything is distinct. So how many distributions are possible? All this will be very useful in binomial and more so in the multinomial theorem. Okay, how many distributions possible?
How many distributions are possible?
Basically, how many ways are there to distribute these 22 balls in these 10 boxes? A sort of version of this we have done before, but this is a harder version of that. Yeah. So
Well,
yes,
from looking for the perspective, the balls, each ball has 10 choices. That's one thing I note.
each ball has 10 choices. Very good. Yeah. Is the question clear to everyone? Okay. All boxes are distinct and all balls are also distinct. Okay. Yes. Each ball has 10 choices. Okay.
So meaning there are 10 possible choices per every ball. That's what it's exact. That's what we're getting.
Absolutely. And I think this is the key part, right? And it's almost everything. Because if each ball has 10 choices, so the first ball has 10 choices, so it has 10 choices. And then after this choice is made, the second ball has 10 choices, right? So this is for ball 2 here, right?
So in each case, the total number of times is being multiplied by 10.
Absolutely, right. So it's 10
So
to
the
the
answer
right.
is 10 to the power 22.
Very good. Is it clear for everyone? Yes. Okay. Nice. So this was very easy, and this is useful, we'll see, but more than this, something else is useful. That is when the exact specifications of the distribution is made. So I'll write that out. So once again, everything is distinct. Remember, people, this is the easiest version of the question. When everything is distinct, is easy. The moment some boxes become identical and balls become, then it becomes a little difficult. But we are not going to discuss that because I think we will not need that. But I'll just discuss one variation of this, which will be useful to know. And it's a good combinatorial counting question in its own. So distributions possible such that. So just for my own convenience, I'll reduce this number such that box 1 gets, I don't know, you can do anything, five balls. Okay. Box 2 gets 7 balls. Box 3 gets 7 balls. So we have, and box 4 gets 1, and box 5 gets the remaining, which is also 1. No, so 12 and 7, 19, and so you'll get 2. Just making the question concrete. Yeah, so now we have specifications. Okay.
It's very specific.
Yes, very specific. Yeah, and this actually makes the question a little difficult, maybe. It depends on the way you see it. Yes.
So simply seeing it this way, again, once again, each ball has 5 choices, at least until the first box gets filled up by 5 balls.
So then that's not a good way to think. I mean, I think, right? Because you won't know which boxes you have filled if you think from the ball's perspective.
Yeah.
Yeah, that is the key. If you think from the ball's perspective, then you won't know at what time, how many boxes, how many balls you put in how many boxes. So maybe in this one, we should change the perspective. And we should think from the perspective of the box. And all the boxes are distinct, so that's also it's
So
okay.
five. So any 5 balls can be chosen for box 1 out of 22.
Right. So I'll just write one thing. Yeah, think from. Yeah, I'll just continue with that. Perspective of box.
This time I have
Right.
to think inside the box.
Yeah. So please say any five. Right. Yeah. Any
Yeah.
five
Any
of
5 out of 22 can be chosen
can be chosen
for box 1.
For box one. Okay. So can anyone else tell me what this number should be? Choosing 5 from 22 for box 1. Can anyone else tell me this? Because I'm sure Soham knows this.
Right, just
Exactly. Very good. So it means you are on that. Yeah. 22 choose 5, I think you meant. Did you say
yeah,
2?
22.
Yeah, 22 choose 5. Okay. So, okay. Now, can anybody else tell me what should we do next?
There is only one person, I think.
Okay. Yes, Akshit, if you also, since this is your first class, so you can also say if you know. What should we do next after we have put, so at this point, what do we have? We have taken 5 balls and we have put them in box 1. Now we have to think about box 2. Box 2. So box 1 is already done.
We are filling these independently, right? Right.
Yeah, in fact,
One
it
by
is
one.
independent. Yes, yeah, one by
One
one.
by one.
Yes, because that way we'll cover
That
everything.
gives a pretty clear idea what's going to happen.
Right. So you can tell me then, yeah, what to do next.
Well, I should tell what Lakshit.
Yeah, I was yes, Akshit, are you following it? I think it's just the first class, so he's a bit hesitant.
Yes, sir.
Okay, no problem. So what do you think we should do next for the second box? So the second box wants 7 balls. How do we give it? Okay, so it's very simple, right? 7 balls he needs. You just give him 7 balls, but how many balls are left? 17 balls, right? So give 7 out of 17. Just thinking in a very simple way. Of course, the exact proof may be a little more. You have to show that you've covered all the cases and such, but let's do the counting. Okay. So give 7 out of 17. 17 is the right number. No, 22.
Yes,
Yeah, it's the right. Yeah. So 17, choose 7. And as Soham also pointed out, it's independent. For every choice you make in the first step, okay, for every 5 balls you choose in the first step for box 1, it doesn't matter. You can still choose 7 balls out of the 17. So you have to multiply this. And then it will be clear. I'm not explaining the other steps. That in the next step, it will be, so you
10
subtract.
10 choose 7. 10 choose
Exactly.
7.
Yes, 10 choose 7.
Then 3 choose 1.
3 choose 1 and then 2 choose
2 choose 2.
Right. So this is one way to get the answer. However, this is a very interesting number. Let me show you. If I ask people to simplify, maybe they will just compute the explicit answer. But really, this is a very interesting number. So I assume everybody knows. Akshit, you know binomial coefficients? I'm sure you have seen it.
Yes, sir.
Very good. Okay. So then I think then you know. Okay. So then you see, if you just do it, you will see that it is not a coincidence that this 17 factorial in the denominator is going to get cancelled by the 17 factorial in the numerator. Not a coincidence. It will always happen, right? No matter what that number, what this number, because this is exactly 22 minus 5, the rest of the balls. So you see, after you do all these calculations, you will get a very clean answer. And you can take that as a formula. And you can also see that you have used this formula in other places before, in permutations with repetitions. But anyways, First, let's get to the formula. So, and there are several interesting variations of this which we will not do which we will not do in this class, because I want to get to the binomial theorem. But you will see that you
It's
will
a very,
get,
yeah, it's very related to permutation again.
it's very, very related, right? And in fact, let's just show how it is related. Not going to more, but I will show why it's related. It is exactly that, right? So this is like a permutation. Can you tell me what problem this answers? What permutation problem? You just set up a problem.
I mean, this reminds me a lot of those types of problems in which you had words with similar letters.
Similar letters, right? Yeah. So we have 22 objects in total, right? And 5 are of one kind, 7 are of the other kind, other 7 are of the third kind, right? So it's like you have 22 22. I can say in terms of multisets. Let's say you have 22 objects, right? And 5 are type 1, right? 7 are type 2, and the other 7 are of type 3, right? The other 7 are of type 3, and so on, right? And this question has this answer exactly, right? And it's the proof is the same, because basically you have 22 places and you have to choose 5 places for the first type and 7 places for the second type, and in the remaining places you have to choose 7 for the first. It's exact same question, right? So one should have actually said this answer directly, but yeah, that's the whole art of it. Yeah. So okay, now you might be wondering what is going on. This is a binomial theorem class, so yeah, but we will see. We'll just right now see the connection with it. Okay, so now I think now we have sufficient this thing, this counting thing. So let's get back to the binomial theorem. Okay, so now I want people to explain me this one, this general one, because now we are more comfortable. So I'll just say, just write it in general. This is a very, very useful formula. It has a name. It's called Vieta's formula. But anyways, so if we expand this,
This formula is about minus b by that thing, right? For it, like what we
sorry,
did for quadratic class 10.
exactly,
So
yeah,
that's pretty
it is
common.
minus. Yeah. So in fact, let me just do it for minus only, because that will be a more interesting one to decide the signs. Yeah, and Dev, we actually discussed your problem 5 minutes earlier, but you stay in the end, I'll discuss it with you. Okay, so yeah, never mind. So this expansion of
It's
this, so
238 volts. Yeah.
no, yeah, actually I sent up, but anyways, I'll talk to you about that later. Yeah, no problem. So yeah,
Oh my goodness, how many people are there in this class?
okay, so now there are a few more people, but in fact not all of them are students. Some of them just want to listen to what I like. Yeah, some of them are my seniors also. So anyways, whatever. It's okay, right? Yeah. Okay, so how do you expand this? That's the challenge. So if anybody wants to say, please say it with the explanations. Yeah.
The first step would be to look at the number of what do we say, brackets, terms in the expression. N terms in total, so our degree of the expression is n.
Right.
So our highest degree would be extra power n. That would be our first term.
Exactly, with coefficient 1. Right. Now the quest is for the second power, that is x to the power n minus 1. What should be done here?
Yeah.
Again,
Sum
maybe
of the,
sum of
I mean,
sum
A1 is equal to
exactly, yeah. But what
equal
sign? What sign should we have? Plus sign or minus sign?
minus.
Very good. Yeah, minus sign. Can you explain why? Though I guess people see it, but still.
I mean, since there are no, what do we say? There's normal subtraction, I think. Yeah,
No,
every term is.
I'm not asking the sign. Why is this the sum? I mean,
Sum of
yes.
the,
Yes.
So we have n brackets. Let's take the first n minus 1 bracket. We'll get x to the power. We can
we're
generate x to the
choosing,
power n minus 1 from that, and then we multiply it to the minus an to get minus an, and
Right.
so on. We can do for the other terms. We can generate x to the power n minus 1 and take that.
That's right. Essentially, we are just going to choose X from, so we have these boxes, right? And you're going to choose X from n minus one of them, but from exactly one
Yeah.
of them, you're going to choose a constant. So that's going to come back with its sign. Okay, all right. And now what should be the second term? We understand the sign should be plus because 2 times will do. Just Dev, can you tell us what should be the second term?
A1, A2, A2, A3, plus A and A1.
Right.
We choose our n minus 2 terms.
Sorry, how many terms?
No, I was telling what the other guy was saying. Why it's plus.
Right. Okay, that's fine. But then how many terms are here in total?
Any two terms are chosen from a total of n brackets.
Right. So that's the n choose 2. Very good. So n choose 2 terms. And here we have n choose 1 terms. That's
Any
n terms.
one term is chosen out of a total of
Right.
yeah.
Exactly. So the next one, I'll just write it in the notation, and you should also try to get used to this kind of notation. A, J, A, K, I less than J less than K. So remember, I less than J less than K is just saying that you're going to choose 3 and they're not their permutations, right? Like you're not going to choose A1, A2, A3 3 times. That will only come once, right? And not in a different order. So we're just going to arrange it in the increasing order and write A1, A2, A3. And A1, A3, A4. And then we won't write A2, A3, A1. Okay, something like that, right? Like this we go on. Very useful formula. We will not use it in this chapter though too much. However, this is okay for everyone, I guess. When we change the sign to plus, right, then all of this becomes much simpler. Plus. Okay, now can anybody tell me how you get the binomial theorem from here?
A1, A2, A3, so on till an equal to some A T, let's say.
Yeah, something like that, right? You can just put it
I mean,
equal
if
to.
you notice with each and every term you go forward, you're choosing one more group of terms out of total of n. If you know.
Yeah.
So from
Right.
the first of all, you chose one from a total of n, then you chose two from a total of n, then three from a total of n, and so on and so forth.
Right.
That's the next thing I noticed.
Right. But then how do you get the binomial? So, I mean, the binomial theorem is a much simpler version of this, right? So in the binomial theorem, all of these are basically y or 1,
Yeah.
same thing. It's a homogeneous thing. You can just put it for 1, but we'll just put it equal to y. So
Binomial theorem is, I believe, a special case of this.
absolutely, yeah. And if you think about it, this is even so simple to prove, and not just prove, like we can see it, right? We can see what's going on. So this, and you put all of this equal to y, because what we have proved will work for general. As Noel was saying, we put it equal to some t, and so then you get your infamous binomial expansion. This, and this will of course become n choose 1 times y, right? Because we'll have, let's just take it one step, y n times, right? This, and here you will have y squares, right? Each of these a1, a2, see, a1, a2 will become y square. A2, A3 will become y square and so on, right? So we'll have a lot of y squares, okay? And so on. And so we will get, yeah, this will be n choose 1 times y to the power n minus 1. And here we recover the binomial expansion, okay? N choose 2 times y square and so on. That's it, right? The binomial theorem just pops out, okay? So we will just do a few more interesting stuff like this, okay? And before moving into the the problem solving JEE type questions, okay? Yes, so we will just do our next thing, but yeah, remember everyone that in 10 minutes or 9 minutes the meeting will end, and then you all can just join back. That is the problem I have. Sorry,
Sir, isn't it supposed to be the other way around? Should be x to the power r into y into n to the power n minus r.
x to the power r, sorry, but you see it doesn't matter, right? It will be the same
Yeah, it
expression
doesn't
in the
really
end.
matter, but
Yeah, but the way we have done it, what I have written is correct. symbolically. The way we have arrived at it, but it doesn't really matter also. Yeah, it doesn't depends. Okay, so let's just do, so we have basically,
the power of x will go down and y will increase. That's
absolutely, it's a symmetric expression, right? Because
Yeah.
n choose 1 is n choose n minus 1 and so on. Wait, someone's mic is echoing.
so
I don't know who it
I
is.
think
Yeah, no problem. So it's a symmetric expression, and that's not a